Okay, so now we're moving on to what are called inscribed angles. An inscribed angle is an angle whose vertex lies on the circle and whose sides contain chords of the circle. When we say on, we mean along the edge. Inside does not count, okay? So I have an angle here. Here's its vertex that's right on the edge, and it is two chords coming down, okay? So that's an inscribed angle. Remember, a central angle came from the center. This is coming from the edge. So the inscribed angle in our picture is angle ABC. Now I'm going to highlight that angle. Because that's going to help me locate what's called the intercepted arc. So the intercepted arc is the arc that lies across the inscribed angle and has endpoints on the angle. So if you follow the angle out to the edges of its chords, this right here is its intercepted arc, okay? And that goes from A to C with the arc symbol on it. So inscribed angle is right here. Its corresponding intercepted arc is out here. All right, so now we can move on to our first theorem. If an angle is inscribed in a circle, then its measure is half the measure of its intercepted arc. So there's that intercepted arc. Here's its inscribed angle. We're just going to take half of that. So half of 70, which you don't even really have to write out. That means it's going to be 35 degrees in that little angle B there. All right, we're going to use that to solve a variety of problems. And we're going to have to remember everything else that we've learned in this unit. All right, so in the first row here, here's the intercepted arc following to its inscribed angle. So half of 82 is 41 degrees. All right, now we're going the opposite way. So if I give you the inscribed angle and I want you to go to the arc, instead of taking half, we're going to double. So doubling 80 is 160. All right, this picture, if you see a few different types of angles. The angle I'm looking for is inscribed because I can see that it lies on the edge of the circle. But then I also see this 40 degrees coming from the center. Those are our central angles. So remember, the central angle is the same as its arc. So if that's 40, so is that up here, arc HS. But then if you follow your inscribed angle, it actually has the exact same arc of 40. But for inscribed angle, the rule is that we take half, so X is 20 degrees. All right, next one. Here's my inscribed angle. Following it to its arc is over here, which I don't see anything. So I have to find that arc first. Well, I see a diameter, and if you remember, that's a semicircle, and those always have 180 degrees. So if that's 92, to find this guy, I'm just going to subtract from 180. And we get 88 for that arc. Now I can take half to find the inscribed angle. All right, moving on to the next row. All right, I'm given my inscribed angle. So to find its arc, I'm going to double. So doubling 50 gives me 100. They want the arc out here. I see I have the two other arcs in the circle. Remember, a circle has 360 degrees. So I'm going to start by adding the two arcs we already have. And then subtract that from 360. Which is going to give us 140 degrees. All right, lots of things going on in this picture. We have to find X and Y and Z. Let's start with X. X is an inscribed angle, so half of 76, which is 38. Going to Y, I have an arc. There's its inscribed angle, so I'm going the opposite way. This time I'm doubling it, so 45 times 2 is 90. And then they want this remaining arc. So again, all the arcs add to 360. Let's start by adding them together. Which gives me 253. Subtract that from 360. Which is 107. All right, next diagram. Looks like I'm gonna have to set up some type of equation. So remember, the inscribed angle is half of that. So there's two equations I can set up. I'm gonna write them both just so you have them. You'll pick your own preference, okay? So the inscribed angle is half of the arc, or we can go the other way and say the arc is double the inscribed angle. A lot of people prefer the second one because they don't want to have to deal with halves. This half isn't bad because I'm just taking half of 88, which is 44. And then it's a simple equation to solve by dividing by 11. Over here, I just have to multiply by 2, so I get 22x, and then divide by 22. So whichever way you want to set this up, just giving you both options, get the same answer. All right, there's a section for you to do on your own, so you can pause here and do that, or do them at the end. I'm going to move on to the next theorem. All right, this goes along with what we just did. It's just a more specific theorem. We're talking about the angle inscribed in a semicircle. So I have a diameter. I have a semicircle here and a semicircle here. Now we already know that semicircles are 180 degrees, right? So if I follow angle DAB, it has an arc of 180. It's inscribed because it's sitting on this circle. Half of 180 is 90. So that's the theorem. If I have an angle inside a semicircle, then it's always going to be a right angle. The opposite is also true. If we have a right triangle inscribed in a circle, then the hypotenuse must be a diameter. All right, we're going to use that on some problems here. So I see a diameter. I have a semicircle. So that angle must be 90 degrees. All right, next example. I see a diameter. So I have a semicircle. So angle W must be a right angle. Now I have a triangle where I have two of the angles and I'm missing the third. Remember, a triangle always has 180 degrees, so I'm going to add up the 90 and 55 to get 145. Subtract that from 180, and we get 35. All right, now they're asking about some arcs. If I follow the arcs back to their angles, let's start with Z here. Arc BC, and I'll use my highlighter for this. Here's arc BC. Here's the edges. If I follow it back, it takes me back to that 35 degrees. That's inscribed. So remember, that's half of what that is, or that's double. So we're at 70. We're going to do the same thing with arc Y. If I highlight this arc to the edges and I follow it back, its inscribed angle is that 55. Double that, and that's 110. The other way to think about this is you have a semicircle, which is 180 degrees. So if that's 70, you'd subtract 70 from 180 and get 110. Lots of ways to get to the answer. All right, let's keep moving on. So we have a diameter, a semicircle. So this must be a right angle here. All right, I see an arc of 120. Again, if this is a semicircle, then that must be 180. So 180 minus 120 gives me an arc of 60 over here. And now we can go back to following arcs. So I'm just going to start with arc BC. If I follow it back to its angle, it's referring to angle X there. X is inscribed, so half of 60 is 30. Two ways to find angle Z. You have a triangle that makes 180 degrees. A little bit faster is if you follow angle Z out, it goes to that arc of 120, so half of 120 is 60. All right, there's 3 of those for you to try, so you can pause now and do those or wait till the end. I am moving on to my next theorem. If 2 inscribed angles of a circle intercept the same arc, then the angles are congruent. Remember, congruence is just a fancy word for equal in geometry. Okay, so here's what it's saying. 2 inscribed angles intercept the same arc. So I'm going to pick an inscribed angle, let's say Q. I'm going to follow it to its arc, and I'm seeing that the arc is PS, right? Remember, it will be half of whatever PS is. I see another inscribed angle, though, that has the same arc. If I look at R, isn't its arc also PS? So even if I don't know what PS is, I know that these 2 angles must be the same. So let's say that was 100. This would be 50, and that would be 50. There's another set in this picture if you look closely. If I look at angle P, it has an arc of QR. If I look at angle S, it also has an arc of QR. So in this picture, there's actually 2 sets of congruent angles based on inscribed angles having the same arc. Okay? And then just one little thing that we'll be using later. Don't forget, I got some vertical angles here in this picture. Everything looks congruent in there. All right, we're going to use that to practice some problems. All right, so I have an arc of 124. If I follow it back, I see X is an inscribed angle. Half of 124 is 62. If I look at where angle Y is and follow it out, it has the same arc. So it is also 62. All right, this one has a lot of things to find, that's okay. So let's start with this arc of 120. If I follow it back, that goes to V, so that's 60. It can also fall back to U. Now I'm going to get the 50. Let's follow that arc back. That can go to W, so half of 50 is 25. It can also go back to X. I just found 4 angles really fast in there. I see a triangle. I have 180 degrees in a triangle, so I'm going to add those up. And subtract from 180. And we get 95. If that's 95, vertical angles, also 95, or you have the exact same triangle, so the measurements all must be the same. All right, next picture. All right, I'm going to start with the vertical angles here. If that's 36, so is that. All right, now I'm going to do some following. So I see 55. I'm going to highlight that angle. So its arc is out here. So if I'm going from an inscribed angle to its arc, I'm doubling. So 55 times 2 is 110. I want you to notice that X has the same arc. If I follow it, it goes to N, and it goes to L, so that's also 55. Okay. Now I see a triangle, 180 degrees. I have 2 of the pieces missing the third, so I'm going to add them up and subtract from 180. So that's 91. We get 89. They're the same triangles, so I'll put 89 in both spots. All right, last thing they want is this arc out here, Y. Let's see if we can follow the arc back to an angle. So it's at P, I'm going to follow it back to L. It's at M, I'm going to follow that back to L. That goes with 89 now. So I'm going to be doubling. So 89 times 2 is 178. All right, next picture. All right, starting with X. I follow it to its arc. That's 40, so half of 40 is 20. There's actually another 20 in the picture, but it doesn't ask us for it, so I'm not going to bother. Ooh, I see these tick marks. Remember, those mean they're congruent. This is an old theorem. If I have congruent chords, then I have congruent arcs. So if this arc is 90, so is that. All right, looking at angle Y, I follow it out to its arc. I need arc AC. Well, I have the other 3 arcs, and I know that all the arcs add to 360, So I'm going to start by adding them together. And we get 220. Subtract 220 from 360, and I get 140. And now y is half of that, so 70 degrees. All right, last one in this section. So unfortunately, they don't give us the corresponding intercepted arc. So if I follow this out, this angle out, I see it's the arc up here. If I follow this angle out, it has the same arc. Now, I don't know what that arc is, but they must both be half of that arc. So these two angles must be equal. So my equation's going to be 3x plus 7 equals 6x minus 11. So I'm going to move like terms over to the same side. So we're just solving an equation here. Divide by 3. And we get that x is 6. Okay, there's 4 of those for you to try on your own. Again, you can pause here or do them at the end. I'm going to move on to the very last theorem. All right, the last theorem, a quadrilateral, a four-sided figure, can be inscribed in a circle if and only if its opposite angles are supplementary. We'll have to go over what that word is if you don't remember it. So I see a quadrilateral. Inscribed means every vertex goes to the edge. It says opposite angles. So let's start with A. So angle A, the angle opposite it is across from it. That's angle C. It says they're supplementary. Supplementary means they add to 180. So angle A plus angle C is going to equal 180 degrees. And so will D and B. That's the theorem. Opposite angles add to 180. All right, let's practice that. So, starting with x, its opposite is 108. So we're just going to do 180 minus 108. That will give us 72 degrees. These two are opposites. Same thing, 180 minus 88. And we get 92. Okay, this one's a little bit more complicated. Let's start with z, because 93 goes with z, so that's just 180 minus 93. So that's 87. All right, next one's much trickier, because I don't have either of these angles. When I don't have angles, I gotta remember to follow things out to their arcs. So let's take a look. I'm gonna start with x. All right, there's angle x. Here's its arc. Look how big that arc is. That arc starts at 58 and continues to 106. So I need that whole arc. So if I were to add these two together, I am at 164 degrees. Now remember, angle x is sitting on the edge, so that's still an inscribed angle. So I need half of 164, which is 82. And now I can pair up with y to subtract from 180. And we get 98 degrees. Okay, so a highlighter is very helpful in this case. All right, last one is just to write an algebraic equation. These are opposites. We know they're going to add to 180. So this angle plus this angle must equal 180. Combine like terms. 2x and 3x make 5x. 9 and 1 make 10. Down to a two-step equation. Subtract 10 from both sides. We get 170. Divide by 5. And we get 34. All right, 3 of those for you to try. Your teacher has the answer key if you'd like to check them after, or you can scan them into me.